Hello everyone, thank you all for coming here. In recent years, we have seen large improvement in EDR and antivirus detection. As a result, attackers now rely more on living of LAN technique. To address this, Microsoft introduced a new AMSI architecture. So in this talk, I will show how to use .NET to bypass the PowerShell visibility. If you have tried AMSI bypass payload before, you will know current payload need obfuscation to work, as you can see on left side picture. But actually, you can use the totally same code, but split them into several pieces, and AMSI doesn't block it. So to find out why, we reverse the PowerShell and study why hitting an enter key could affect the PowerShell decision. And I will show how to use this behavior to weaponize it and how to detect it using Symbolic solver. So before we started, allow me to introduce ourselves. My name is Jr-Wei. I work at TS1 as a senior threat researcher. I focus on threat hunting, detection engineering, and malware analysis. My co-author, Shenghao, he is a team lead at TS1. He has 15 years of experience in machine learning, malware analysis, and reverse engineering. So here is our outline. We first will go through the Windows file list attack and highlight why PowerShell is so often abused. Second, I will show AMSI bypass payload that rating usually use. And third, I will explain and I will show how to use .NET gadget to bypass the PowerShell visibility. And then finally, I will share how to find a new de-obfuscation method in PowerShell internal. And I will introduce our new tool, AMSI.fail. So let's start with the question. Why focus on PowerShell? In typical intrusion, attackers usually choose C2 framework and choose the stager based on endpoint. And after gain initial access, they will choose the command line tool or PowerShell as their reverse shell. Yeah. So when choosing a command line tool, they usually use a third utility or Encode to drop the malware and run it. However, the defender like EDR, NDR, or antivirus are already watching that and will block that. So typically, attacker will use the PowerShell to perform the persistent privileges collection and the most importantly, bypass the antivirus and the EDR before they drop any malware. So understand the whole workflow. Blue team may wondering if we could block the malicious PowerShell before early enough, could we prevent the rest of the attack? The short answer is yes. But the true question here is, could we block the malicious PowerShell early enough? Actually, it is hard. With the limited visibility by Microsoft, they only have two options. The first option is script block logging with 4104 and the ETW traces, both of which are originated by the PowerShell PSETW log module. The second one is AMSI, which is the only one that can block the malicious PowerShell before they execute it. And AMSI cooperate with third-party EDR and antivirus perform the detection. So let's start with how a hacker bypass the AMSI. In this year, we explore all the public AMSI bypass payload and group them into three attack surface. First one is .NET patching, and the memory patching, and the provider-related patching. Each attack surface are mapping to AMSI workflow, as you can see below the red line. So in this chapter, I will go through each attack surface. So first one, .NET patching. They use the attacker use .NET behavior to override the .NET variable. So one of the critical variable here is init file, AMSI init fail variable. So this variable stores the AMSI initialization status. So override is attacker could bypass the AMSI. The second one is memory patching, which happened at the communication between PowerShell and AMSI. So the function AMSI scan buffer controls all of the scanning workflow and the return address, return value. So attacker could override this and hooking this function to return a non-malicious or normal status call. The third one is provider related. It happened at the communication between AMSI DLL and the provider DLL. So when AMSI initialization, they will call all the provider into the memory. And after that, AMSI will call providers DL get clear objects function. So this function in Red Hat HR 2022, there is a research shows that we can override this DL get clear object to interrupt the initialization status in AMSI. However, the situation changed this year when Microsoft introduced a new architecture that used the machine learning on the AMSI. So we're wondering which attack surface are blocked now. So we test and we review all the payload and find the two key points. First is AMSI DL scanning, AMSI DL patching and the provider DL patching are blocked now. Even the string obfuscation. And the .NET patching with the string obfuscation that still could bypass the AMSI. So we're wondering, we feel confused why the Red Hat top tier research are blocked, but the legacy old school bypass trick .NET patching that still could use. So let's see the two payload. As you can see, the memory patching payload is relatively easy to detect because the combination between the log library, get proc address, and the virtual protect. And the .NET patching is hard to detect because there is no key signature, because the key signature is obfuscated. So let's show a problem. AMSI don't have enough visibility in .NET layer. So we decided to dig deeper inside the .NET level, .NET technique to bypass the PowerShell visibility. So let's see how use .NET gadget to bypass the PowerShell visibility. When PowerShell compilation, there is the function perform security check are called to review the command line using the AMSI and the event logging. So as you can see here, the AMSI perform security check call the AMSI scan content with the text function, string. So it shows that AMSI is based on string level detection. So with the string level detection and lack of execution context, third-party EDR is hard to use the dynamic analysis to detect the malicious AMSI bypass. So that is why AMSI bypass still could work. The previous research focused on AMSI bypass, AMSI utility, but we want to go further to PowerShell and how cooperate with AMSI. So let's take a look. Here is a payload. We use the invoke mimics and the base64 to encode that and call IES invoke expression. So invoke mimics is a malicious command. So let's see how AMSI reaction. So because the command passed to the parser, so first AMSI triggered the AMSI scanning because the targeting to the IEX with the variable name. And second, when the PowerShell resolve the variable, because our invoke mimics are encoded, so we will decode that, PowerShell will decode that. But in this area, AMSI doesn't trigger. But when IEX call and the reference to this variable, they will trigger the second scan and the targeting to the invoke mimics. So we understand the whole workflow. We will know there is two conditions AMSI will be triggered. First one is when PowerShell pass the command to the parser, they will trigger the first AMSI scan. And the second, when the PowerShell, that the resolved variable is triggered by the IES or script block create, that will trigger the second scan. So we understand AMSI scanning trigger the period. So if we want to bypass the AMSI, what is our concept? So our concept is here. We use we should execute a command and without compile and parsing. So is that possible? Actually, in .NET there is a framework called .NET Deserialized. In .NET Deserialized workflow, PowerShell will try to parse the serialized data and directly convert it into an in-memory object. So as you can see on the right side, it's a deserialized workflow. So we use an XML reader and use the create instance. They will create an instance in the memory. Then they will finalize the initialization. After that, they will call all the methods in the instance. So this gives us an opportunity to call arbitrary function without parsing and compiling. So there is no visibility in the whole workflow. So let's see how PowerShell processes the .NET deserialization. So we use the presentation framework with the XML reader to parse the serialized data. So as you can see, AMSI only trigger one scanning because the command passed to the parser, they will trigger first scan. But there is no second AMSI scanning targeting to the resolved string or serialized data because the data is directly converted into the XML object. So we understand that we can use the .NET deserialized workflow to train our payload. And thanks for the previous .NET deserialization research, we have over 18 vulnerable gadgets could be used. And it is hard to, routing is hard to detect this kind of payload because there is too many combinations. Okay, so here is a classic AMSI bypass payload we just talked about. That use the reflection to override the AMSI init-fail, right? So, but the defender already blocked this. But we still could use the .NET deserialize to weaponize this new payload as a new payload. So let's see how it works. So here is a free payload, and we will convert it into a gadget. So first, we use an object data provider gadget to do that because object data provider have everything we need to call arbitrary function. Okay. So as you can see here, we use the assembly log to retrieve the system management automation, this namespace. Then we can use the namespace to call the get type to retrieve the get utility. After we get the utility, then we can call get field to get the AMSI init field using the object data provider. So after that, we have the AMSI init field. Then we can call the AMSI init field we can call set value to directly convert that. So here is a demo. We use Windows 11 with 24H2, and here is a paired defender. So we first use the WinPong. We download the WinPong hacking tool. So AMSI will block that because obviously there is a hacking tool. So it is malicious. So we use our serialized payload with the serialized workflow. As you can see, we use the base64 to encode our serialized data. So we execute that didn't be blocked by my AMSI. So we execute this WinPong again. So this time that doesn't be blocked because we bypass the AMSI. So we can prove that using USC bypass payload in the WinPound to show that all the operations were not blocked by AMSI. Okay. So now we successfully using the .NET deserialize to bypass the AMSI, but even we bypass the AMSI, third-party EDR or antivirus still could use the like the ETW traces to get the command, to trace the command, right? So our next challenge is if we want to bypass the whole PowerShell visibility, our next challenge is how to bypass the PowerShell ETW traces. So when we researched about this topic, we found that BC Security, this team is already researched about that and introduced a new technique called script block smuggling. So, but this script block smuggling still have some problem. We will talk about this later. But the concept of this technique that is using during PowerShell compilation, during PowerShell parsing, the script block will be split into several blocks. Like M block that will store the code that will be executed, the extend block that will store the code that will be logging and will be scanning. So normally this M block and the extend block should be the same command line text, but attacker could craft an M block with the different command line to bypass the event logging. So that is the payload of the script block smuggling. As you can see, the spoof AST used a script block, create a script block that using the command write output, nothing special. This command that will be logging, but the other one, the execute AST, create a command that will be re-executed. So next, the script block AST with the new function that will help the two script block combine to one script block. So using this script block to execute, then there will be a new script block and execute it. So, however, this whole script block smuggling payload are already be blocked by AMSI Defender. So we still could use our .NET deserialization to wrap it as a new attack surface and to bypass the AMSI. So we use the same technique as the previous one. We use the object data provider to help us to train all the payload. And as you can see, here is an example. We just see the script block AST with new, right? So we can use the object data provider to convert it with the specific argument. Okay, so here is a demo. So before we demo, let me introduce this. Because we want to bypass the event log, so there is a first command that will be login. Here is write output, nothing special. And we truly execute the command is start process calculator. So let's see the demo. So we use the same environment, Windows 11. And as you can see, here is the original script block smuggling. So there will be, let's trigger the script block smuggling. That was, as you can see, they are blocked now because AMSI will block that. And as you can see, Defender knows this is script block smuggling. So it is identified. So let's see how to turn this payload into a new one. So we use the .NET serialization workflow. Here is .NET serialization workflow. And let's see our gadget. So we have first gadget is the command that will be logging. Is the spoofing the gadget. And the second one is the gadget that will be truly execute, which will be execute a calculator. Okay. So let's see the event viewer. The rest of the gadget is the script block smuggling gadget. Okay. So here is the event viewer. We use the 4104 to trace the PowerShell command, right? Yeah. So we clear it before we execute our payload. So let's go to execute our payload. So as you can see, that's successfully execute and without blocking. And here is a calculate execute. And let's see how 4104 tracing data. So first one is the prompt, which is not important. And the other one is write output, nothing special, which means that we execute is calculate, but the login command is write output, nothing special. So we successfully using script bus modeling with the .NET deserialization to bypass the event logging. Yeah, so now in addition to bypass the event logging and AMSI, we also deep dive into the AMSI provider architecture. So to extend the Black Hat HR 2022's research AMSI on-chain. So we just said AMSI provider will be loaded into the PowerShell. So in Defender, there are two DL will be loaded into a PowerShell. First is NP-OAV DLL, and the second is NP client, which will be loaded because they need to communicate with the Defender service. Okay, so we want to know if there is an unusual way to interact with two DL to turn their service off or turn their detection off. So as you can see, after we reverse engineering, we found that NP client DL have two interesting functions. First is NP config uninitialize and uninitialize. They will write and remove the configuration. So as you can see here, the NP config here will be loaded into the configure library holder, which will be scanned. When scanning, the NP config holder will be used. So if we delete the command using the NP config initialize, they will turn the Defender off. So let's see the demo. We use the same environment here. Yeah, we the same environment here, and as usual, we use the WinPong as our target. So we first use a download string to be a WinPong, and they are blocked as usual. So here is our payload. We use the NP client. We load the NP client DL, and directly call the NP config uninitialize, which is PowerShell's advanced. Yeah. So after we execute it, we re-execute a WinPong again. So this time they didn't get blocked because we turned the Defender off using their own API. So by using, we can prove that using a USC bypass module to show that we download the WinPong and also load into and execute a attack. Yeah. Okay, so now we use in this chapter, we use the two deserialization workflow to gadget to bypass the whole PowerShell visibility. And we also use we also find the NP AMSI provider, NP client have some problem that can be abused to turn themselves off. Okay, so let's come back to routine. So how to solve the detection problem? And we will propose the new de-obfuscation method in PowerShell internal. When passing compiling to execution, AMSI only targeting precompiled text, right? So this makes it easy for attacker to hide their true intent using obfuscation. So we need to address this problem, we need a new method to track the PowerShell parsing operation. Okay, so in this chapter, our target is we want to detect the malicious PowerShell that AMSI or string-based detection could not discover. That's our target. So we target the .NET patching with string obfuscation because that's the only one AMSI cannot detect. And we found a famous website, AMSI.fail, that have a lot of this kind of payload. So here is one of payload. As you can see, the payload de-obfuscated all the string and it could be de-obfuscated using 3 steps. So first step, we use the mass on the number and turn that into a string. So first the obfuscated string is management. And the second one is the using a normalized with font string to turn a letter into a diacritic and base letter. After that, they use the stage P with NN to remove the diacritic mark. Yeah, so after that, the string will be automation and the ASI utility. And then we use they use the mass on the number again to hide the true string ASI session. Okay, so after that, we go through the de-obfuscated workflow and find the true intent of the command, right? So here is a command. They use the get type with ASI utility and they use get field to call the ASI session. So ASI session variable store the ASI initialization information. So clearing it prevents the ASI from scanning. So it shows that string de-obfuscation is very important in detection PowerShell, because if we cannot find the string like the ASI utility, we cannot find the ASI session, then we can not understand what that's meaning and how to detect that. So if we want to go deeper inside the de-obfuscation in PowerShell, we need to dive into the PowerShell internal. So as you can see, we use the command. When command read into the PowerShell, they will go to pipeline processor and into the parser and become a script block. Then the script block will be split into the several statements, and AST visitor will take care of the statement and convert into a syntax tree. So that's the parsing operation. After that, they will call scan module like the ASI, script block login, and the execution policy. If nothing violates the policy, they will cause the compilation and run on the .NET COR. So when PowerShell parsing, the AST visitor will try to resolve the variable name, symbol name into a real object. So as you can see here, 1 plus 2 multiplied by 3 will be converted into a function style, and then we'll check the plus and the multiply will be converted into a token, a real object. Okay, so second is echo nohead 2025. This command will be converted into a lambda style function with 2 arguments, echo and the string nohead 2025. So in AST visitor framework, they have a lot of different kind of visitor. One of notable visitor is constant value visitor. In this visitor, they will try to inspect every token and they will try to resolve every token's compute data, which means that if there is a data like the A plus B, they will try to resolve the string to the AB. So this kind of computing, they will in the constant value visitor. They don't need any compute pipeline. They don't need any external I/O. They will directly resolve that in this stage. So let's see an example. We obfuscated our command with string obfuscation and the char casting. Then we go through a constant value visitor. The result will become a IES calculator, which is the obfuscated string. We obfuscated string. So next example, we use the previous payload, and as you can see, after constant value visitor, they can get the real data from the and automation. So this shows a key point. This shows a key point that we can use constant value visitor to help us de-obfuscate the obfuscated string, like the string concatenation type or char casting type. We can use constant value visitor to de-obfuscate it. And so, like the left side, the management, automation, and ASI utility, we can use constant value visitor to de-obfuscate it. So, however, there's the constant value visitor only could handle the static resolution. So like the dynamic obfuscation type, like the join operator, like back64 and the format string, they cannot be de-obfuscated by constant value visitor. So we need other solution to help us de-obfuscate this type. So here we get back to the PowerShell internal. As you can see, the session state store the variable and the function and the execution context. So every object, if they need to access the variable, they need to go to the session state to retrieve the data. So if we could track the session state, then we could get the de-obfuscated variable. So after we reverse engineering this session state, we find the get variable value and the set variable value in this function. So here is the 3 example. We use the dynamic obfuscation type like the join operator and the back64 and the format string. And after that, enter into the variable A, variable B, and variable C, the session state will store the de-obfuscated string, de-obfuscated data. So now we have everything we need. We can de-obfuscate the static and the dynamic obfuscation type. So typically, when we use the de-obfuscated tools, they always need maybe rule, policy, or regular expression. But we propose this approach, we don't need any policy or rule because we use a PowerShell internal to help us de-obfuscate it. Okay, so we built a website tool, web-based tool for reverse engineer or for routing to de-obfuscate the command more quickly. So here is our architecture. We use the left side is our front end and the back end, and right side is our Symbolic solver. So the operation is when script block passed to the Symbolic solver, there will to be a script block and then split into the statement, and AST visitor will solve that. And we built a just-in-time intersect architecture to help us collect all the data above, like the passing result and the passing session state data. So here is our output. We have 5 output, and each output mapping to a passing operation. So first one statement shows the script block that will be split into several statements. So user could use the statement, this field, to understand and overview the obfuscated data. And the second one is solver step in shows the passing result. And third one is tainted symbolic constant shows the result from the constant value visitor, which will help us to de-obfuscate the string concatenation and the char casting. So the third one, the fourth one is expression tree, shows the expression result from visitor, created from visitor. So user could, and the routing can use this to write a rule because this kind of rule can prevent the symbol-based obfuscation. So finally, is variable list shows the variable data like variable name that we tracked using the session state. So we can use variable list to de-obfuscate the dynamic obfuscation type. So here is our demo. Left side is our obfuscated string, and right side is our solver. So here is the statement can split into 3, and here is a parser. And the 10 symbolic solver shows the static resolved data like 2025 and welcome AMSI.fail. The expression tree shows the expression result, and here is, as you can see, they are all standardized symbol. So after that, the variable list shows the like a dynamic de-obfuscated string and the data and the name. Yeah. So next level, because our goal is to detect the malicious command that we can let string-based detection cannot discover, right? So we use the AMSI.fail's website. So here you can see we copy the payload and check that can successfully bypass the AMSI. So here is, as you can see, the execute, and we can use the invoke mimikize to check that can successfully bypass. So here you can see it's not recognized, mean we already bypassed the AMSI. So we pass it into the, our solver. Okay. So there are 5 output. The statement shows there is a variable in the initialization. So we can go to variable list to check what is the data. So here you can see the first 2 variables show the like null and the memory address. So let's go step in shows the parsing result, and the symbolic constant shows the static result string like the measurement, automation, and then phone D, and like the session stat. So AMSI session stat. So as you can see, we can use the our tool to de-obfuscate the string to help the blue team have the .NET level visibility. So with this .NET level visibility, we can perform a detection using this kind of tool, because we can use the download an artifact, and this artifact will include the parsing result and the de-obfuscated string data. So we can use the YAR rule or similar this kind of rule to monitor this sensitive data or string to perform the .NET level visibility, because we have the obfuscated string and the parsing result. So here is our takeaway and the conclusion. So in this talk, we go through the rating and the booting in PowerShell. And in rating side, we use the .NET deserialization to help us bypass the whole PowerShell visibility. And we also use the AMSI provider. We find that there is we can abuse the DL to bypass the defender itself. And it shows that pure string is not enough and it's not practical for detection. So we found that PowerShell internal could be used to de-obfuscate it. So we built a tool using this kind of concept. So here is our POC, and we already public a website, HTTP AMSI.fail, which is our website. And if you have any unresolved command, you can try on this website. So here is all, and our presentation end here. Thank you.